Okay, I'm going to go ahead and get started. We do have a lot to cover. It's going to take us the whole time. What I want to talk about real quick first is I will not be live on Friday. I have a conference that's from 9 to noon on Friday, so it won't be live. But after I get done with this class, I am going to pre-record your 8.1 and put it in your week 7 folder. Okay, so it will be in there. The video, the YouTube video will be in your week 7 folder. So you'll be able to go still watch it. It just won't be live. Okay, so that's on Friday. So what's due on Sunday this week is the review for test 2, and 8.1. So again, the 8.1 on Friday won't be live. It'll just be in your week 7 folder for you. Okay. We went through number 11 on Monday. So we're starting with problems like number 12, which gives us the graph of a function, a x squared function. It says x plus 1 squared. It's a true-false question. And it wants to know, will this graph be translated to the right 1 unit? Is that true or false? Okay, so let's think about this. This plus 1 is on the inside of parentheses, right? What do we know about numbers that are inside? We do know they shift horizontally, but what is it about the inside numbers? They're going to go opposite the direction that the sign says. So this plus 1 is actually going to shift this parabola, this x squared graph, to the left 1 and not right 1. So that's why it is false, right? It doesn't shift it to the right, it shifts it to the left. All right, number 13. Gives us another parabola graph and then asks us several questions about it. It has f of x equals x squared minus 10x plus 16. The first thing it's going to ask me is, where is the vertex? Because the vertex pretty much gives you the information that you need in order to answer the rest of the questions. So what I'm going to do is I'm going to put this function into my y equals and graph it. Because remember, it doesn't tell me where to find the vertex on the calculator, but I can go to a function on the calculator that'll help me find the minimum or maximum value. Remember, regular parabolas look like this, and their vertex is at the bottom, which means it's the minimum. The upside down parabolas look like this. Its vertex is at the top, and it's its maximum. So as long as we know whether or not we're finding the minimum or maximum, we can find the vertex. So let's go to our y equals, clear out whatever's in there, put in the x squared minus 10x plus 16. X squared minus 10x plus 16 is my function. Graph it. And this one's going to be a regular parabola, right? Oops, hang on, I gotta change that. It's going to be a regular parabola, right? What would have made it be upside down? It's upside down when the x squared is negative. So since it's not negative, it's a regular parabola, which means if I want to find the vertex of this parabola, I need to find this minimum value, which means I need to go to where you find the max and min is in this calc area. So hit second calc. If you're finding the minimum, you need to go down to 3. Now, the two questions that you're going to have to answer is your cursor on the left side? And then is it on the right side? So if this right here, this X and Y tells you where your cursor is right now. So I know that it's at 0, 16. So it's somewhere way up here. So I know it's on the left, but I'm just going to hit my right arrow until I see it to make sure. So there's my cursor. It is on the left side of the parabola, so I'll hit enter. Now it tells me go put your cursor on the right side. So I go right arrow to the other side. Anywhere on the other side of the parabola, it doesn't matter as long as you've crossed through that vertex and gotten to the right side. Hit enter twice. This right here tells you where the vertex is, and 4.9999996 is the same thing as saying 5. So it's at 5, -9 is where the vertex is. And remember, your vertex is an ordered pair because it is a point. So make sure you put it in an ordered pair symbol there. Now, the second thing it asks me is the A or B. Does the parabola open upward and have a minimum? Or does it open downward and have a maximum? Well, if you're looking at your parabola, it opens up, right? It's irregular, which means this is its minimum value. So let's see. Going to sketch. So I'm just going to say so the parabola, the vertex is at 5, -9. It had the minimum value. Now remember, when you're talking about value in a parabola, the value is always the y coordinate. So my minimum value is -9. The next thing it's going to ask you is what is the range of this parabola, which is asking me what are all the y values? What is everything that y is on this parabola? Well, let's see. We have found that the minimum y is -9. Which means that's as low as the range goes. The y values never go below -9, right? They don't ever go below this point. So -9 is the lowest part of the range. From that point, it goes up on both sides, which means your y values are going up from -9. So my range, and I'm going to put a bracket, and I'll tell you why in a second, starts at -9, and then the y values go up forever from there. So why does one part of this range have a bracket and the other part have a parenthesis? Well, first of all, infinities, whether they're negative infinity or positive infinity, always use a parenthesis because the difference between using a parenthesis and a bracket is whether or not you want to include this number. You can't, infinity is not a specific number. You can't include infinity. Infinity just means on and on forever. But do I want to include -9 in the range, which means on this parabola, is there a y value of -9? Yeah, this y value right here is -9. -9 is part of your y values of that graph. So that's why the -9 has the bracket around it, because I want to say the y being -9 is included on that graph. Now, the last part of this problem wants to know where is this graph increasing and decreasing? When you're using increase and decrease, first of all, you're going to, let's look at where this is occurring. What are your y values doing all the way until they get to this point? They are decreasing, right? So this is my decrease side. Once they get to this point, what do they start doing on the other side of that point? They start going up. So this is my increase side. So label your increase and decrease sides. Now, increasing and decreasing is also in interval notation, but we always use parentheses when we're talking about increase and decrease because I am decreasing until I get to this point. But am I decreasing at this point? No. It's where I stop decreasing and get ready to start increasing. I'm not decreasing or increasing at this exact point. That's the one point where I'm not doing either, right? I'm not going down or up. It's like I'm just there, right there in that one spot. So that's why I'm going to use parentheses. Also, when you're talking about decrease and increase, you're using the x coordinate of that vertex. So let's see. If I'm coming in from the left, I'm coming in from negative infinity until I get to this point. And I use the x coordinate. So from negative infinity to 5 is where I am doing what? That's the decrease side. What do I start doing once I get to this point? I start at the 5 to go up, and then I go up forever. So if I start increasing at 5 and go up forever to infinity. Okay? Number 14. This is another problem. It's going to be exactly like this, except my x squared is going to be negative, which is going to flip this parabola upside down. It's going to ask me all the same questions about it, though. This time the function is f of x equals negative 4x squared minus 4x plus 1. So that's what I'm going to put in my y equals. So negative 4x squared minus 4x plus 1 in my y equals. I'm going to graph it. So just like we knew that was going to happen, it flipped my parabola upside down. So this time, the first thing it's going to ask me is, where's the vertex? Right? That's what gives me all the information about the parabola, or the information that I need to know. So this time, when I go to second calc, I want to find the maximum, right? That's the maximum this time, since it's the top of the parabola. So second calc, this time I'll go down to 4 to get to the maximum. Left bound, let's see. It's hard to see my cursor. I see it blinking right here. I'm going to go over to make sure I see it. Over on the left side. So there's on the left. So hit enter. Now hit your right arrow to go back across the top, over to the right. And then hit enter twice. So let's see, where is this maximum? And it even tells you, there's the maximum. It's the vertex right there. And it's at negative 0.52. This brings up something new. Now, when you're typing this answer in on number 14, and it says the vertex is blank, look what it also says. Integers or fractions, which means it doesn't want that decimal. So remember how to do your decimals. If you don't know what negative 0.5 is, type it in. Negative 0.5, hit enter, and then hit math. Turn your decimal to a fraction. So math, enter, enter. So it's negative 1/2. 2. So let's see. I'm going to go back to my graph and draw this out. So we just found that the vertex is at negative 1/2, 2. This time, the parabola opens downward, right? It's upside down, so it opens down. So it has a maximum value because the vertex is at the top. So what's its maximum value? Always the y-coordinate, which is 2. So its maximum value is 2. That's as high as the y values go. So this time when I'm doing the range, the highest value is 2, which means all the other y values are below 2, right? Because what happens here? This is the highest. This is the maximum value, which means all the other y values of this upside down parabola are below 2, which means my range ends at 2. 2 is my stopping point. It's the highest point. So that's why the 2 is at the end there. And again, it has the bracket around it, right? Because 2 is part of this graph. I do definitely have a y value of 2 at that on this graph. Now, all the numbers below 2 would go all the way down forever. So if I'm going down forever, where is that going to be? Negative infinity, and infinities always have parentheses since you can't include them. And then the increase and decrease of this graph. So let's see. Label it first. What are your y values doing on this side? They're going up until they get to the maximum. So this is your increase side. Once they hit this 2, they start going, the y values start going down. So that's your decrease side. So I am increasing until I get to this point, which means I am increasing coming from negative infinity from the left till I get to this point. So that negative 1/2 is where I stop increasing. So I'm increasing all the way from the left until I get to negative 1/2. So I start increasing at negative infinity until I get to this point, so I increase to negative 1/2. Then what happens? What happens when you hit this maximum right here? What do you start doing? You start decreasing. So where do you start decreasing? You start decreasing at negative 1/2, and then you decrease to the right, going to the right forever to infinity. All right, number 15 is the toy rocket problem that we worked in this section that is talking about the toy rocket being shot vertically into the air. So what shape is that going to make? If you shoot a toy rocket up into the air, it's going to go up and up and up for a long time, or however long, until it gets to a certain point. And then what's it going to do? It's going to come down. So it's going to make the shape of an upside down parabola. Okay? So it tells us the function that it makes here. It tells us that the function that we have, that they have figured out for us, that makes the shape of this parabola is h of t equals negative 16t squared plus 112t plus 4. That's the function that makes that shape. It wants to know two things. It wants to know how long did it take to get there and what is the highest value of that point? So two things. If I can find this maximum, the maximum height will be your y, right? That's your maximum value. The x value is how long it took you to get there. So that's the number of seconds that it takes you to get to that point. So all I really need to find is that point, which is the maximum of that function, that parabola. So go to your y, y equals on your calculator. We don't have t's, just put in x's. Negative 16x squared plus 112x plus 4. And then graph it. Remember, it should make an upside down parabola. So if you noticed, it was started down here and went up way off my calculator and then came down. So my maximum is somewhere up here. So what we can do is, again, I don't care. I don't even have to see it. I just need to make sure at the first my cursor is on the left side of it, go all the way to the right until I get over. I can see it over here on the right side in my second calc. I'm going to go find the maximum. So second calc, since it's upside down, I need to find the maximum. Hit enter. Now let's see. It says my cursor, I can see it blinking right here. And here's my parabola. So is it already on the left side? It is. So hit enter. Now it wants you to put it on the right, which means I need to hit my right arrow until I get up and over that vertex. So watch your y's. What's going to happen at that vertex? My y's will stop doing one thing and once I get all the way up there, my y's will stop going up and then start coming down. So watch your y's, 87, 105. So they're still going up, which means I'm still on the left side of the parabola. I just got to keep going up. And at some point, I'm going to see it over here. Oh, look, they started going down now. Went from 199 to 195. So they're coming down. So I know that my cursor is now coming down over here somewhere. And I could actually go ahead and hit enter, right? I've already crossed through the vertex. I know I'm on this side, the right side of it. Oh, there it is. Hit enter twice. So let's see. X is 3.5, Y is 200. Which means it took 3.5 seconds to get here, and the highest that it ever went was 200 feet. So the maximum height was 200 feet. Number 16. Getting into the radical functions, which we did a bunch of square root functions. The first thing it's going to talk about is the domain. So remember, when you have a square root, and you're talking about putting that function on the graph, you want what is underneath. What's underneath here needs to be positive, right? If you're underneath the square root, unless you want to get into the i's, and i's are imaginary numbers, you can't put them on the graph. What's underneath there needs to be positive. So whatever it is, in this case on number 16, it's 4x minus 7. Needs to be positive. Well, what makes you positive? You have to be greater than or equal to 0, right? Because if you are below 0, what does that mean you are? That means you are negative if you're below 0. So in order to be equal to or above 0, this right here, whatever's under there, just set it up as that equation. 4x minus 7 needs to be greater than or equal to 0. And then solve it. So add the 7 to both sides. So 4x needs to be greater than or equal to 7. and divide by 4. So x needs to be greater than or equal to 7/4. Number 17. Graph the function f of x equals the square root of x minus 7. And it's a multiple choice. So if you know your transformation rules, you don't even have to graph it, because the graph says find where f of x equals the square root of x minus 7, with the minus 7 inside that square root. What do inside numbers do to your graph? They shift it horizontally, left or right, but you go opposite the sign, which means that minus 7 is going to shift this graph to the right 7. So if you're looking at your multiple choices, there's only one of those that has the square root graph shifted to the right 7, which is this A, right? It's the only one that's gone to the right. Number 18. This one's tricky, so I'm going to kind of give you a clue on how to pick out which one. Let's go and put it in our y equals. Now remember, to type in square root, you'll hit your square root function is right above your x squared. So there's your square root, which means you need to hit the second square root. Gives you your little square root in your y equals, and put in 8x minus 1. 8x minus 1. And let's graph it. So here's my graph. Look at the graphs you have to choose from. Here's why none of them look like this. Look on your y-axis. Look at the highest that these go. They go to positive 5. The lowest it goes to is negative 5. The reason I'm showing you this is because look at B and D. They look so similar. Look at my graph. It looks flatter than B or D. See how steep they are? But the reason is, since these y values only go to 5 and mine go to 10, right? My y, the top of my y-axis goes to 10. If you wanted to change that, you could. I'm going to show you another way to figure this out, though. And you'll be able to magnify your graphs on this problem with the little magnifying glass. But let's use our domain rule. That's going to tell you something about this graph. The domain that I found 2 problems ago. What is underneath here? Needs to be positive, right? It needs to be greater than or equal to 0. Well, let's solve it. Add 1 to get rid of the minus 1. So 8x is greater than or equal to 1. If I divide them both by 8, now I know that the x values start or have to be greater than or equal to 1/8, which means this shape it's going to have the square root shape, which is this. But this says the x values. Here's my x values. This is telling you where this point, where this shape starts. It can't be below 1/8, which means it starts just to the right in the positive area of the x's, right? That's where the x starts at 1/8. X cannot 0. So when you magnify B and D, if you magnify it on your test or your review, it actually goes to the other side, to the negative side of the x's. And B's, you'll notice, starts right to the right of the x on the x-axis. So that's how you would choose between those two. Figure out where your square root graph would start by doing this. So since it starts in the positives, that means you can't have a graph with where there's any part of it that is on the left side of that origin, right? Then that would make your x's be negative. So that's why you choose the one where it starts right to the right side of it. I know that's kind of confusing, so hopefully the one on your test will be a little clearer than that. All right, the next one is getting into our piecewise functions. I'm going to do 19 and then 23 because they go together. And then I'm going to do the rest of them, but I'm going to work 19 and 23 back to back. Number 19 gives us a piecewise function, and it says f of x equals, and then it has three different pieces. One piece is x squared, one piece is x minus 2, and one piece is 5x. Your graph is x squared for when x is less than negative 2. Your graph is x minus 2 for when x is between negative 2 and 4. So it'll show like this. Negative 2 is less than or equal to x, which is less than 4. And your graph is at 5x for when x is greater than or equal to 4. So there's three different pieces to this graph depending on what your x is. And this tells me to find f of negative 2. So what you do first is go find where negative 2 falls into these pieces. So let's look at the first piece. This says if x is less than negative 2. Is x less than negative 2? No, it is negative 2. It equals negative 2. So that's why you choose this piece, right? Because it has the x equals negative 2 in it. Which means, what piece does that mean I use? So if you fall in this area, this is what you use to plug into. So I pull in the x minus 2. Now, once I find the piece that I'm plugging into, which is the x minus 2, whatever is in here goes into that x. So let's plug it in. So if I replace the x with negative 2, bring down my minus 2, it gives me negative 4. So that's 19. Again, I'm going to work 23 and then come back to 20. 21 and 22. All right, 23, same kind of thing. It has a function, h of x equals, again, it has three pieces. One of the pieces is negative 2x minus 17. One of the pieces is just 3. And one of the pieces is x plus 7. So there's three pieces depending on what your x is. The first piece is for when x is less than negative 7. This next piece is for when -7 is less than or equal to x, which is less than 3. And the last piece is for when x is greater than or equal to 3. So I've got 3 pieces, depending on what your x is. This wants me to find 4 different things. It wants me to find h of -9, h of 1, h of 3, and h of 7. So I'm finding 4 different things. So again, what you do first is take this number, this -9, and find which piece it falls into. So let's see. -9, is -9 less than -7? And it is, right? -9 is below, it's more negative than -7. So it's below -7, which means it does fall into this piece. So this is what I'm using. -2x minus 17. Once I have the piece to plug into, whatever this number is, put it in that x. So I'll have -2 times -9 minus 17. -2 times -9 is positive 18. Bring down the minus 17, which gives you 1. So done with that piece, or that part. Now I'm going to find h of 1. So let's see, what piece is that going to go into? Is 1 less than -7? No, it's bigger than -7, so it's not this piece. So let's check this one. Is 1 in between -7 and 3? On the number line, 1 is between -7 and 3. So this is the piece I'm using. So when I come over here to see where I plug it in, I just see a 3, not even a 3x, just a 3, which means if you fall in this piece, there's nothing to solve. Your answer is just 3. Now I'm finding h of 3. So this is the one these are the kind you have to be careful of. This place says right here, x is less than 3. This piece says x is greater than or equal to 3, which means it falls in this piece, right? Because I need to know when x equals 3. So what piece am I using? X plus 7. Put the 3 in the x spot, so I have 3 plus 7, which gives me 10. And the last one, I'm finding h of 7. So let's go see, where does 7 fall into here? It's not below -7. It's not between -7 and 3. 7 is greater than 3. So it again falls in the last piece, right? Because 7 is greater than 3, which means I use this piece. So x plus 7. Your 7 goes in that x spot, so I have 7 plus 7, which is 14. So that's 23. Now remember, now we're going to come back to 20. All right, I'm going to draw out number 20 as best as I can. And name the important points. So here's what number 20 looks like. It wants to know all the places where it's increasing, decreasing, and constant. So before I go through and label the increase, decrease, and constant, remember we're going to type this in interval notation using the x values of those specific points. So let's go through and name these points where things start and stop happening. For instance, I increase until I get to this particular point. Okay, so this particular point, if you look at it, is at negative 1, 2, 3, 4, 5, 6, 7. Looks like it's up 1. So it's at negative 7, 1. What is important is your x values of these points, because that's what we talk about when we're increasing and decreasing. So let's see. This one is at negative 5, negative 3. This one's at negative 2, negative 3. This one's at negative 1. And then it looks like it's at 1.5. It looks like it's right in between the 1 and the 2 on the y, but it's not really important. What's important is that you know the x value. So it's negative 1 and then 1.5, which is 3/2. Again, that particular number is not that important. So let's go through and label now where everything's increasing and decreasing. So on this side of this point, my y values are going up. So this is an increase. Once I get to this point, I start going down, which means this is a decrease. This point right here is constant, right? It's just going straight across. Once I get to this point, I go up again. So that's another increase. And then when I get here, I go straight across again, which means that's another constant. So I highly recommend going through and labeling your points with their coordinates, especially the x coordinates. And then go through and write in where things are increasing and decreasing. Then when you get to actually answering the question, you have everything written out. Remember, you're using your x coordinates. So let's see, where is this graph increasing? It's increasing in 2 spots. Increasing here to here. And then again, from this point to this point, it's going up. So I have 2 spots that I need to, 2 intervals that I need to talk about. Where is this one starting to go up? All the way from the left end of the graph until it gets to negative 7. So if I'm coming from the left end, that means I'm coming from negative infinity until I get to this point, which is negative 7. So there's one increase. There's your other one. Again, if you've already labeled your points, you're just talking about the x coordinates of these points. The x coordinate of this point is negative 2 until you get to this point, and its x coordinate is negative 1. So that's the other increase, negative 2 to negative 1. Talking about decrease, well, there's only one spot where the graph is going down. There's only one decrease, which is right here. You've already labeled the point, so you know these 2 x coordinates. It starts to decrease at negative 7, and then it decreases until it gets to this point, and its x coordinate is negative 5. And then there's 2 constants. Let's see, a constant from this point to this point. So again, I already know the point's x coordinates, negative 5 to negative 2. And then it's constant again, starting here and going to the right forever. So it starts being constant at negative 1, and it's constant forever to the right, which goes to infinity. All right, we're going to go over a little bit. That was number 20. Let's go to 21. All right, it gives you the picture of a parabola. Then it tells you what its vertex is. And the vertex is at the top, which means it's its maximum. And it's at 2.5, 5.25. Okay, so it literally gives you that point. Then it says, does this have a maximum or a minimum? Well, the vertex is at the top, which means it has a maximum. The relative maximum occurs at, so what is my maximum value and what x does that occur at? So it asks me two things. The maximum value is blank. Actually, it asked it backwards. The maximum value occurs at x equals blank and has a value of blank. So remember, the value is always your y coordinate. When you're talking about values, it's always y. So your value is the y, and then it kind of even gives you the clue. It literally says x equals what? We'll just put in your x coordinate there. So the x is 2.5, and it has the maximum value is 5.25. And then it wants to know where is it increasing and where is it decreasing. Well, if this is the maximum, that means it's going up until it gets there. So this is your increase side. It gets to this point and then it starts going down. So that's your decrease. So it's increasing all the way from the left until it gets to this point. Talking about increase and decrease, you always use your x coordinate. So I'm increasing from the left, which means I start increasing at negative infinity until I get to 2.5. Once I get to 2.5, I start to decrease. So I decrease from 2.5 to the right forever, so to infinity. All right, 3 more. I know I'm going over. Okay, so it tells you what these 2 points are, which is the numbers that you need. This point is at -8, -1. This point is at -2, -19. This is called a relative maximum because it's at a top of a parabola part of the graph. So it's got a where it stops going up and starts going down. So that's a maximum. This point, it stops going down and starts going back up. So this is its minimum. So the first thing it wants to know is the relative maximum is. So the maximum is blank and it occurs at x equals blank. And then it's going to want to know your minimum. So what is your maximum value? The value is -1, and it occurs at x equals -8. What is your minimum value? Your minimum value is, the value is always the y, so it's -19, and it occurs at x equals -2. And then it's going to want to know its increase and decreasing parts. So let's look. It's going up until it gets to the maximum. So this is an increase. What's it do? Once it gets to this point, it starts going down. So there's your decrease. And then it gets to this point and it starts going up again. So another increase. So it increases in two spots. This spot and then again on this interval. So it increases all the way from the left until it gets to -8. So negative infinity to -8. That decreases, but then it increases again. So here's another increasing interval. So it starts increasing at -2. And then it increases to the right forever, so to infinity. And the decrease, there's only one decreasing interval. It's this part right here where it's going down. So its x's are from -8 to -2. All right, we already did 23, so now we just have 24 and 25 left. And they both deal with the difference quotient. So I'm going to write the difference quotient up here. So here's my difference quotient. F of x plus h minus f of x all over h. And it wants me to know for the function f of x equals -8x plus 5. Find the difference quotient. So the first thing I need to do to find the difference quotient is find f of x plus h. That means go to this function, and wherever you see x, put an x plus h. So if I do that, I'll have -8. Instead of x, I'll put x plus h. So I just replace the x with x plus h, bring down the plus 5. Minus, because that's what the quotient says, is minus. Then in parentheses, you just rewrite the function and put it in the parentheses. This whole function, -8x plus 5, comes in that parentheses. The denominator is going to be an h, but I'm going to throw that in at the end after I simplify what comes up top. So this -8 needs to distribute. -8x. -8 times h is -8h. Bring down my plus 5. Now, this second part, when this negative distributes to both of these, it's going to make everything that's in this parentheses cancel something up front. So look what it turns this -8x into. This right here, the negative turns that negative into +8x. And it turns that +5 into -5. So like I said, everything in these parentheses, once you distribute the negative to them, will cancel something up front. So this -5 has a +5 that it'll cancel. This +8x has a -8x, it'll cancel. So look, the only thing that is left is this -8h. Now remember what your denominator is, which is h. And your h's cancel. So your difference quotient is -8. Now remember, we did talk about this when we did this section. If your x is not squared or cubed or have anything done to it, it's just plain x, your difference quotient will always just be that number that's hooked onto your x. Last one, 25. This one, our x will be squared, which means it's not just going to be the number hooked onto the x. Let's see what this function is. This one's a little more complicated. f of x equals 9x squared plus 3x plus 2. Let's find the difference quotient. So remember, the first part of the difference quotient tells me to go to my function, and wherever I see an x, I put an x plus h. So I see it in two spots this time. I'm putting x plus h's in both of these spots. So I start off with 9, put in parentheses x plus h, then I got to square it, plus 3, again, in place of the x, I put x plus h, bring down my plus 2. Now remember, the second part of the top, or the numerator, is to subtract the whole function. So this right here, you put your minus, your open parentheses, and then all of those terms come in those parentheses. So 9x squared plus 3x plus 2. And then simplify this. Now remember, we did this. The first thing that needs to happen is you need to do your x plus h squared. I'm not going to FOIL all that. Remember what I said to have handy. Anytime you see x plus h squared, it's going to end up being x squared plus 2xh plus h squared. If I FOILed that out. So this right here, I'm just going to bring down the 9. X plus h squared turns into this. So x squared plus 2xh plus h squared. Now I'll distribute this 9 to it. 9 times x squared gives me 9x squared plus 9 times 2 gives me 18xh plus 9 times h squared gives me 9h squared. Now I'll distribute the 3 to this parentheses. So that'll give me plus 3x plus 3h. That remove those parentheses, I'll drop down this plus 2. Now remember what distributing that minus does. It makes everybody in that last parenthesis cancel somebody up front. It turns this into a negative 9x squared, turns this into a negative 3x, and it turns that positive 2 into negative 2. Again, all of these terms will now cancel something up front. So this minus 2 should have a positive 2 to cancel. There it is. This negative 3x should have a positive 3x to cancel. There it is. And this negative 9x squared should have a positive 9x squared to cancel. And there it is. So let's see what is left. I still have 18xh plus I still have 9h squared plus I still have 3h. And now remember, what is the denominator of this difference quotient? It is h. So here's how I'm going to simplify this. All 3 of these terms have an h in them. So I'm going to pull that h out. I'm going to do it a little different than we did on that day. They all have an h. So I'm going to pull the h out and put what's left in parentheses. H is a common factor that I can pull out of all of those. So if I take an h out of this first term, if I pulled this h out, what's left? Just 18x. Plus, if I take an h out of this second term, since I had h squared, if I take one of those h's out, I have 9h left. Plus, if I pull the h out of this term, all that I'm left with is 3. Now remember again, what's your denominator always of the difference quotient? It is h. So your h's cancel, and here's your answer. All right, so I know that's a lot. That's the second half of the review. I did up the time on the review and the test to both be 90 minutes instead of 75. so that you'll have more time to work this one. So remember, no live Zoom on Friday, but I am going to pre-record section 8.1 and put it in your week 7 folder. So I will see y'all next Monday.